In this lecture, we're going to roll up our sleeves and get into some networking. So our objectives are to consider a history of networking and interconnectedness rather. Some protocols we've seen in the past, what we use now, web services and JSON, a nice directory of web services called xmethods.net. We'll take a look at how to create our first online DAO. We're not going to finish it completely, but we're at least going to get it structured and set up correctly. We're going to revisit declaring a variable and instantiating an object, and we're going to look at the permissions required for networking, which is android.permission.INTERNET. We're also going to look at how to debug with F5 and look at a network call in progress. So I believe I've gone through this presentation in an earlier video, or at least part of the presentation, so I might hit it in a little bit fast forward mode in this presentation, because our focus this time is to go ahead and do the actual implementation of a network call. But first, I did want to talk a little bit about the history of networking. If I go back to when I was in college, we typically considered a computer to be a PC. And the PC you'd plug in and have a printer. And really, there wasn't always a networking layer. There wasn't always a network that connected computers together. Many times computers operated in complete isolation. So you'd have the scenario where transferring data from one computer to another meant printing something out, mailing it to someone, and that other person would receive it and type it in. And it's amazing the amount of clerical labor that happened up till about the turn of the millennia, where there were just a lot of people who were hired as pure data entry. And in college, a lot of times that was my job, was to do inventory entry or something like that, where I'd take a written report or a printed report and type it into another computer. So in the 90s, networking became a lot more popular. And with networking became the ability to interoperate from one unrelated software package to another. So it wasn't always very straightforward, but it was something that offered quite a big return, because you could eliminate a lot of non-value added labor of just rekeying data. So it started with some concepts like CORBA, the Common Object Request Broker Architecture, which allowed us to talk from, say, C++ to Perl, or C++ to Java, or Perl to Java, or anything like that. So we could talk from different programming languages to each other. Now with CORBA, CORBA was a little bit tricky because it did have to bridge between different programming languages, which added a bit of complexity. So purely within Java, there's something called RMI, or Remote Method Invocation, which made things really easy to talk among two different Java processes. The trick there being that they both had to be Java. So it's very effective, very efficient. It just was Java only. Microsoft had its proprietary networking or interoperation protocols called COM and DCOM. The component object model and the distributed component object model, if memory serves right. Again, work great if you're working within the LAN Microsoft, but it was really tricky to talk from one computer to another. So around the year 2000, sometime around then, this concept of web services took off. And the idea of web services is that we could define a standard way for computers to talk to each other and for software to talk to each other, typically by using an XML standard. And this became popular very quickly and is still popular today. Web services, many times we typically think of them as being XML based, okay? And it doesn't matter what programming language is on one side and what programming language is on the other, because the XML is kind of the common language that binds them both together. Here's a really nice directory of web services that I've used for quite a long time. I mean, probably 10 years. These are some web services that you can call to get things like currency conversion, stock quote. One that's really interesting is GeoIP, so map IP address to country. So this one's pretty interesting. You can What you can do is you can do, and I think we talked about this in an earlier lecture where we were talking about networking, but you can take an IP address and get a rough idea of where that user is located. So there are web services that will do things like this. Some of these web services are free. Some of them do have a subscription required, but nonetheless, this is something we really want to think about when we think about a mobile app, because we want to consider the value that we add by mixing together data or integrating data from different sources. Sometimes those sources are web services. Sometimes those sources are on the phone itself, like the camera, the GPS, the accelerometer. All of these things are sources of data that we can leverage. So Xmethods is a nice directory of those. Okay, so moving on. We'll talk about the other bullet points as we proceed. REST, representational state transfer. This is a lightweight version of how we can do web services. One option it gives us is that we can either do XML or we can do JSON, JavaScript Object Notation. JSON is a lighter version, a kind of lightweight way we can communicate, and I know I've shown this a couple times before. It's worth seeing again. This is a JSON feed from plantplaces.com. So we see if I say common equals maple, I think I also had like a combined name equals maple. Let's see if this works. Hopefully, yeah, it does. Okay, so combined name, I think I got on there twice by mistake, but combined name equals maple. Combined name means that it could be either genus or species or common name. Let's just redbud. Try with redbud here. Yeah, okay, there we go. So combined name. So this is a JSON feed. We have an array of plants. Then we have name value, ID 83, name value, genus Cercis, name value, species Canadensis, name value, cultivar none, name value, common and eastern redbud. And then on the next row, we start our next plant. So this is what JSON looks like. We'll take a deeper look at JSON in our next presentation. But that's one of the nice things about REST, is that it allows us to communicate with this lightweight JavaScript object notation. HTTP methods, again, I think we talked about this before. Get, post, put, and delete. The one we're going to look at today is get. Okay. Apache HTTP, these are the classes that we're going to use in our network layer. We're going to use HttpGet. Okay. What does get mean? Get means that we provide data to the website or the web service using name value pairs, just like you see right here. Okay, so name value. I don't know why it's duplicating. All we really need is like this. But it provides us with these name value pairs like so, which is how we can communicate data. Response handler determines what to do with the response. We're using here something called a basic response handler, which just says, okay, when I call this URL, it's going to return string data to me. Now, what do I want to do with that string data? That's what the response handler is for. HttpClient glues the two of these together, the request and how we handle the response. So request is like a website URL we're making a request to. A response is what we do with the data we get back from that request. Then the client mixes those two together, or marries those two together. So these are four classes we're going to use in our implementation. HttpGet, response handler, HttpClient, and then also the object types, default HTTP client, and basic response handler. Okay, JSON, we'll look at this a little bit more in a later, I have several more slides here to talk about JSON. We will look at that in our next presentation. Right now we're going to focus just on networking. Okay, so I'm going to go back to our project, and in our lab, let me resize this so we can see it entirely on one screen. I'm going to go back to our project, and we know that in our last video we refactored our fetching logic for plants into a stub, which is going to give us a predefined and hard-coded list of plants that match a result criteria. And then we're also going to have our online plant DAO, which is what we're doing now. So the online plant DAO, what's the job of that? Well, that's really good to put in JavaDoc. So let me put some JavaDoc at the top, and we'll say fetch, or let's say access and write. Let's just say access plant data in a raw type and convert it to plant objects. I mean, that's good enough. Okay, so the fetch plants method, we're going to say given a search term, return a matching collection of plants. Always a good idea to do JavaDoc. Also, if you're copywriting your code, or even if you're not, it's oftentimes a good idea to put a copyright statement at the top that explains what your copyright parameters are. Okay, now you see, we already know a little bit about this, don't we? We know where we're going to put our search term. We have this URL here with combined name equals red button, and this URL is largely going to stay intact. The only part that's going to change is that combined name. So if I say here string request URI, universal resource indicator, boom, there we go. Let's leave off that part that might change, the combined name, okay? And we'll terminate with the semicolon, okay? So what we'll do now, we'll say, let's go ahead and put HTTP to start this as our protocol. We're putting together, okay, and again, I'll put this in comments. Request URI is the web service, I mean, for lack of a better word, let's say JSON service URI that will give us plant results. Okay, view plant JSON PL combine name equals. Now what I'm going to do is I'm going to append to this, and I know this is falling a little bit off the screen. I'm going to append to this the search term. There we go. So I'm going to say the combined name plus search term. Okay, there we go. And save. Okay, now we need some way to actually make this request and get a response. Now the trick is these classes that we've seen before, HttpGet, ResponseHandler, HttpClient. To actually make a network call, we're going to need about 4 lines of these put together. And we don't want to copy and paste those every time. A better idea, I'm going to Control S to save and Control M to resize this. A better idea might be to take all that information and put it in one central location where we can call it as frequently as we want. So in other words, take that boilerplate network stuff, put it into a method. The method will accept a string representation of a URI and will return back string data that matches that URI. So I say right-click New, and then I say Class, and I'm going to call this, let's see, we're going to call it Network DAO. Okay, everything else is fine, and then I'm going to choose Finish. Okay, Network DAO, of course, we want to give this some JavaDoc. I also want to Control M so we can see this on the big screen. I'm going to say low-level network functions that can be called by any higher-level DAO. Okay, and again, what is this network DAO going to do? Best to describe that by creating a method and putting JavaDoc on that method. Public string fetch string URI. That works. Let's see. I want to stay consistent here. I'm actually going to change this to request because that's what I used. That's what I've used in previous videos. So let me change that to request. There we go. Okay. Control S, public string request string URI. Okay, it's mad at me because I don't have a return statement yet, but let me go ahead and put some JavaDoc. We're going to say invoke a URI or URL and pass back the string result we get when we invoke that URI. Okay. The address, typically HTTP, that we want to call typically, let's say starting with, okay, return the data we get when we invoke this address. Okay, and save. Okay, so in the request method now, what I'm going to do, and again, this is pretty boilerplate. If you're doing any kind of network connectivity on your app, feel free to pretty much copy paste what I'm doing here. So I won't be offended if you use it. Let's start with an HttpGet. HttpGet represents the request that we are making. Making. Okay, HttpGet, and then we'll say we'll just call it HttpGet equals new HttpGet. Okay, and we pass that literally the URI. Control-Shift-O to organize imports. Okay, now we're going to say request handler handles, response handler. Response handler handles the response from this request. Okay, response handler, you remember that generic identifier string, and then we'll say simply response handler equals new response handler. Actually we're going to call this a basic response handler, a default implementation. Okay, Control-Shift-O, organize imports. Okay, HttpClient glues together the request and the response. Okay, HttpClient equals new default HTTP client. Okay, and Control-Shift-O, again, organize imports. You see all of these are coming in from the Apache library org.apache.http, which is what we use for networking in Android. Okay, now make the request and response happen. Okay, and so we're going to say HTTP client, and we simply need to invoke execute. Okay, and let's say once this comes up, okay, we're going to say HttpGet, which is our request, and then response handler, which naturally is going to handle that response, and it's just going to pass the string back to us. Now, what we're going to do is a couple things. First of all, Control-1, we're going to say assign to new local variable, and we see that it is going to give us a string. We're going to call that string response. Okay. Next, we're going to say return the response. Okay. Return, and no, that just fell off screen. Response. Easy enough. Now, one trick is we see we're still getting a red line here, and that red line is because it doesn't know what to do with the exception. We haven't talked about exceptions or try-catch blocks yet, so that doesn't make any sense. So we will talk about exceptions in a future lecture, but until then, just Control-1, and in this case, let's say add throws declaration. Okay, that'll be fine. We'll just leave it like so and choose save. Okay, again, this is pretty boilerplate stuff. If you're going to do any networking and you want to take a URI and get a response from it, feel free to reuse what I have here. As always, I'll take this example from tonight and I will post it on GitHub. You're free to copy and paste as much as you wish. Okay, the next thing we want to do then is go back to our online plant DAO, and we see that we have here a request URI, and what we want to do then is make the request. Okay, make the request. Okay, well, to do that, we're going to need to get a reference to the low-level network DAO. Remember how this works. To declare a variable, we need a type. That type can be one of the 8 primitive types like int, double, float, byte, boolean, short, long, or it can be a more complex type that is made up, that can be decomposed into those primitive types. A complex type is something like a class, like the one we just made. So a class can be a variable type. So we're going to say variable type network DAO. So variable requires a type and a unique name. Network DAO, that's fine. Equals new network DAO. Okay, what's on the right side of the equal sign? We're creating a new object of type network DAO. What's on the left side? We're declaring a variable of type network DAO, and the name of the variable is network DAO. Okay, and then we save. Okay, so declare a variable on the left. Variable requires a name and a type. Equals is the assignment statement. It means do what's on the right, take the result of that, and assign it to what's on the left. So new network DAO is invoking a constructor. Okay, now send the request. Yeah, we'll just, we'll consolidate here a little bit. Make the request. We'll cut that, move that down. Make the request network DAO dot, we called it request. That was our method, right? And notice that when I highlight over, remember all this? This is that Java doc that I entered before, which is a good reason to have Java doc, because when you refer to a method, you will see that Java doc. If that method's in another class, that's especially helpful. So we're going to say network DAO.request. Request URI is going to be fine. Terminate with a semicolon. And we know a couple things. We know that this is going to return a response, so I can control 1 and say assign statement to new field. That's fine. Actually, I should have made it a local variable, but that's fine. For this, we're going to call it, we're going to call the variable, whoops, did that too fast. As a matter of fact, let me undo that. Try that one more time. Control 1, assign to new local variable. We're going to call the local variable raw plant data. Okay. Okay. Once again, we're going to have to deal with an exception here. Yeah, I'm tempted to catch this again, but let me control 1. For the moment, I'm going to surround this with try catch. And again, we don't know what a try catch is. We'll come back and explain that in a future lecture. Okay, so make the request. I'll put that in our try block. Whoops, Control Z, Control X, Control V. There we go. And then what we're going to say is we're going to make a to-do, and we're going to say parse the raw data into a series of plant objects. We're not going to do that yet. We're going to do that when we talk about JSON in a future lecture. So I'm just going to leave that there right now kind of as a to-do. Also, I generally don't like returning null. Let me clean that up a little bit. After I've done all this cleanup, then we'll take a look through the debugger. Okay, so we're going to say declare our return type. We're going to say array list, whoops, plant, all plants, equals new array list plant. Okay, and then we're going to say we'll go ahead and return our return type here. Even if it's empty, which it will be for now, at least we're not returning null. Okay, so we know we have a little more work to do. We know we have to get that parsing down, but at this point, we at least have enough where we can do a little bit of debugging. I'm going to hold down Control and press M, make sure I've saved everything, and then I'm going to wire this up in the plant results activity. Control M again to focus on the plant results activity. What I'm going to do here is I'm going to change, I'm going to copy this line. This is in our activity, this is in our actual user interface. So I'm going to comment out the line before. What I'm going to do now is instead of calling plant DAO stub, I'm going to call online plant DAO and save. Okay, Control-Shift-O, organize imports, and we're all set there. Notice we're in the do in background method. Remember, in Android version 4 and greater, we have to do network operations outside the UI thread. We cannot do network operations in the UI thread. The reason being, network operations tend to take time. If we do them in the UI thread will lock while it's waiting for the network call to come back, and then the user gets frustrated and the user keeps tapping on our application, and then we get the dreaded application not responding, which, trust me, is something you don't want. So that's why we have to put them in a separate thread. So you see we're here in this do in background method, and you see that we're within an async task. Now, by the way, if you're watching this video and you haven't seen any of my previous videos, this video is one of a series. It's part of a playlist. You can see the videos roughly in the correct order in that playlist. So if there are things I'm talking about you're not familiar with, like async task and do in background and threading, just take a look for the playlist for this video. This one I think is called Winter Spring 2014. Beginning Android or first Android project, something like that. And you can see all the work I've done on this project to this point. And also this project is on GitHub. If you look on the videos, typically I'll put the GitHub link in the comments. And every time I do a video, I typically commit my changes. So each video corresponds, maybe 2 or 3 videos together, but roughly each video corresponds to a GitHub commit, so that you can see the progress of changes as I'm making changes. Okay, in any case, this is our UI. Our UI is going to reach into our online plant DAO that we've just made. So Control-Shift-R, an online plant DAO. And here's our online plant DAO. Online plant DAO is going to reach into the network DAO and do the low-level request out to the web. So with all that being said, I'll Control-M, and I will open this up in the emulator, which will take just a moment. Okay, and I did have the emulator pre-started. I'm going to just check on it. While this is loading in the emulator, one note, my last video I talked about how to speed up your emulator by using the Intel Atom and the Intel hardware acceleration. At the time I said one drawback to Intel Atom is that it can't be used with the Google APIs. Right before this video, I updated my Android SDK, and I saw that as of API level 19, yes, you can use Intel Atom and the Google APIs. That's a huge bonus, because the Intel Atom processor, the Intel Atom virtual devices will speed up processing significantly. So just a note to self. And again, if you're not familiar with that, that's another video on our playlist about why is my emulator so slow. So we're going to let this launch. I'm going to pause for a moment, and then when it is up and running, we'll take a look and debug through. Okay, the application is launched. I'm going to choose Select a Plant. And again, we know this isn't giving us results yet, and it won't until we actually describe what JSON is. But at the very least, we can take a look and watch this request happen. Okay, plant name, we're gonna, let's say Redbud. We've had a lot of luck with Redbud. Let's go ahead and say Redbud. And if all works well, when I hit search, we should go to the results screen, and it should hit our breakpoint, and we can step in from there. Okay, sure enough, I see that the breakpoint has engaged. Give it a second to catch up here. Okay. That's an unrelated breakpoint. I'm going to go ahead and play through. Okay, here we go. In our screen now, we have our search term. I'm going to choose F6 to step over. Okay, notice we're constructing an online plant DAO. Step over. Now we're going to go into that fetch plants method. Step into F5. Step into will take us into this method. Okay, we're creating our return type. We're creating our request URI. Now we're creating that low-level network. Ooh, yes, okay, good. I thought I forgot something. Now we're going to step into that low-level network and make this request, that low-level network DAO. Again, most of this is boilerplate. Our HttpGet to make a request, ResponseHandler to handle the response, HttpClient to marry the two together, and then finally we're going to make the request. This might take a moment. You might notice when I choose F6, it's going to take a moment, and that's because it's actually fetching live data. So F6, you see we lose control for a second. Uh-oh, and it looks like I have an exception. Okay, I'll step forward, see if I can get this exception. Oh, security exception. You know why? Because I didn't listen to my own advice. I said early on, I said we're going to need to request permission android.permission.INTERNET. Now, normally, one second. Normally, when I'm making a video and I find I make a mistake, what I'll do is I'll go back and erase the video till that point where I made the mistake. I'll re-record. You'll never know I made the mistake. Trust me. In most of the videos you're watching from me, I've made several mistakes. I go back, rewind, re-record. You never know the mistake happened. In this case, I'm not going to do that for two reasons. Number one, so you'll see this security exception. Number two, so you'll notice what happened when I got the exception. You'll notice that it went to this class file editor, and I had to hit F6 a couple more times before I actually saw the security exception come up. The reason I do that is I had several comments this week from students doing projects that said, I'm getting source not found, what do I do? And this pane does not help us. When you get this source not found and you get something like this Android jar, and you look up here and you see async task or thread pool executor, probably an exception happened. The best thing to do in that case is to look at the variables tab, look for a variable called E or EX that has an exception, and then look for the message. That's what we really need. The trick is you typically won't get that message right away. You typically have to choose F6 or step over a couple of times before that variable appears. So I said normally at this point I would have just rewound and undone everything I did. But because that came up several times this week, I did want to show you what that means. If you get this source not found, hit F6 a couple more times, look very closely in your variables tab, and look to see what the exception message is. Okay, I'm going to go to Android Manifest now. I'm going to add the permission, and we're going to try again. So I'm going to click on the Permissions tab. I'm going to choose Add. I'm going to choose Uses Permission. Okay, and I'll recenter this so we can actually tell you what. I'll just Control M it so we can look at the big screen. I press Control M. Still is not easy to look at. For name, we're going to choose android.permission.INTERNET. Okay, and I'm going to save, and I'm going to Control M again, and I'm going to right click, and I'm going to debug as Android application, and let's try again. It should be just a moment as the emulator launches again. Okay, we'll choose to launch to that same, let me go ahead and clear this error, and with any luck. And that's what happens when you get that message Android emulator has stopped or Android application has, or Plant Places has stopped. That's typically what that means is an exception was thrown. Okay, it looks like I did it twice there. Let me try one more time. Okay, and deploy. And we're back. Let's try again. I'm going to choose Select a Plant. Okay, again, we're going to choose our old standby, the red bud. A plant I can't wait to see come into bloom, and as I'm recording this, we're only about maybe 3 weeks away from the infamous red bud bloom. Okay, I'm going to hit search, and this is where we'll see our breakpoints hit. We know we're going to first get one that doesn't really matter. As a matter of fact, I'm going to go ahead and click that one off so that it doesn't distract us anymore. So we click, and then I play. Okay, and now we're going to try one more time to step into this fetch plants method. Okay, and we're going to get our URI. We're going to create that low-level DAO, and now I'm going to F5 step into this DAO, step over, step over, step over. Hold your breath, cross your fingers. This is where it broke last time. This is where it's actually making the response. I will say one thing I'm happy about while I was watching people, very good, we got our response. While I was watching people work on the latest assignments, I was impressed with how well people in an introductory Android class were really mastering the debugger. That's an important skill that many textbooks tend to save for the last chapter, but if you're doing any kind of work, any kind of programming at all, it's more important to learn the debugger well than to learn anything else. I'm going to mouse over response and take a look at what we got here. This might look a little bit familiar. It'll take me just a moment to get this resized properly. Look at what we have. Do you see this? Plants, and we have Cercis canadensis. You know, I'm not making any of this up, but if you look at that, it looks very similar to what I actually got when I did the same query over the browser. So at this point, we should be very comfortable that we have data that's live. We have live data that we've received from the Plant Places JSON web service. Okay, and we know that it's a dummy implementation, so we're just going to go ahead and play through. But we do see now, and probably might even fail because I gave it no data. We do see now that we're able to get live data. So what do we need for live data? A quick review of what we've covered today. Number one, in our activity, we must run any network operations in a separate thread. In a previous video, I created this one called async task, and you see that our network operations are happening in the background thread. Number two, we need some kind of DAO or some kind of class that's going to coordinate working with a lower level DAO, getting back raw data, and then creating smart data, creating plant data out of that. That's the step we haven't completely gotten to yet, but we will in our next video. Okay, next, we need to determine what our URI is, or what our address is, and what our variable search terms will be. Then we need to pass that down to a lower level reusable DAO. And in this DAO, we're doing some networking operations, basically about 4 or 5 lines. Again, feel free to copy and paste these because they're boilerplate. The get is our request. Get is one of several methods we could use. Another one that's common is post. Response handler handles what we get back when we make that request. HTTP client marries these two together with an execute statement, and then that will give us back our string data. When we receive that string data, we have to decide what to do with it. We're going to need to do, in this case, a little bit of smart JSON parsing to turn that string data into some more intelligent plant objects. So that's a look at networking. Next video is on JSON. I look forward to having you join me there, and that will pretty well wrap up our series on networking and integrating data from outside sources. Thank you.